Hello everyone, welcome you to the YouTube channel of Developers and Coders Club NIT-A. So now we'll be solving the problem C, MEX repetition of Pinelli round 2. So we will be given an array A which contains pairwise distinct integers from 0 to n, and in one operation we can consecutively go for each I from 1 to n in order, and we will replace AI with the minimum exclusive of the entire array. Okay, so I hope you already know what is minimum exclusive. If not, you can go through this para, you will understand shortly. And after key operation, we just need to print how the array will be looking like, right? So let's see a sample test case. So if we take n equal to 3, operations are 1, and the array is initially 0, 1, 3. Okay. So after the first operation, let's see how we are doing the first operation in detail. Okay. Then from the next time onwards, I will be doing the first one operation in one go. But now I'm explaining the whole operation, what is happening in for the one operation. So at first I will go to the index 0. Then for that index I will take the minimum exclusive of the array, which is 2. Then I will go to, then I will just make an array. Then again I will go to this array, this index 2, and I will find the minimum exclusive, which is here 0. Then I will go to index 3, this index 2, and here it will be 1, the minimum exclusive. Now this is the resulting array after the first operation, right? So after the second operation, what will happen? I will actually do this stuff again, but now without taking any more time. So this will be 3, 2, 0, right? And after the third operation, it will be looking like this is 1, 3, 2, and after the fourth operation, it is 0, 1, 3. Now we can see after n plus 1 operation, the array repeats itself, right? So whatever be the value of k given to me, if k is greater than n plus 1, then I can update my k as k modulo n plus 1, right? Because after n plus 1 operation, this array becomes the same as the initial array, right? So I don't need to do stuff again and again. I can only do it for k times. Okay. So also now I cannot do it for k times. If I'm doing this for k times, then the time complexity will be n into n. Why? For every index I'm doing that, right? For every index I'm finding the minimum exclusive and updating it. So it will take me more than, it will be more than v of n square. So let's try to find a solution in less than v of n square. So I can see that, let's try to observe some patterns over here. Now after the first iteration, like what I can see after the first operation, the 0 is shifted towards the right and 1 is shifted towards its right, and 3 shifted to its right, and it becomes 2, right? Now after the second operation, the last element only changes, right? Here I can see this is the initial. If I try to remove this much, this is the initial array, this is after first operation, right? So what I can see here, uh, only the last element is getting changed, right? After every operation, after one operation, the last element is getting updated to the minimum exclusive, that is 2, and if I am rotating it, and other elements are shifted towards its right, 0 is shifted here, 1 is shifted here, and 3 is updated to its minimum exclusive. And again I can see here the 1 is updated to the minimum exclusive of the entire array, which is 3, and they both are shifted here. Then 0 is again updated to this, and these two are shifted here. 2 is updated to the minimum exclusive, 1 is shifted here. Okay, this is the pattern that I can see over here, right? So what I can do here, if I directly go from this array to this array, what pattern I can observe? The pattern is something like this zero, this first element, it will be remaining the same as it is, right? I can see that here my zero, like first of all I need to know what is my k. Okay, then I can do other stuff. Okay, so if k is 2, that means after two operations I have to return my array, right? So if I'm doing all this stuff at once, then the last element is getting deleted, right? The last element, it is getting removed. If I am doing these two operations, then the second last element is getting eliminated. The second last element I cannot find in this array, right? Then if I am doing it three times, then I cannot find the zero in this entire array, in the third array, right? So I can observe that if I am given this array, then if there is the kth operation, then the n minus k plus 1th number, it will not be present in my array. Got it? So the number here, it will be, suppose for third iteration, it will be this 0, right? So this number will not be present. This 1, the 0 is not getting present in the entire array, and the remaining things I will just print on the very front. This 1 and 3 I will print first, then I will print the minimum exclusive instead of the 0. Let's try to take some other example other than this, because this is very simple but not intuitive. So let's take some other example. Okay, so by taking this array, so this is 5 3 0 4 2 1 6 9 10 8, right? So this is the initial one. Now after the first operation, how would it change? This will be 7. The minimum exclusive will come here, right? The last element is getting updated, and all other elements will be shifted towards its right. So this will be 5 3 0 4 2 1 6 9 10. Okay, so after the second operation, what will happen? This will again be the minimum exclusive is 8 now. Now 8, then 7 5 3 0 4 2 1 6 9. After the third iteration, I can see it will be remaining the element left here is 10, then 8 7 5 3 0 4 2 1 6. I'm just shifting all elements towards its right. Okay, and just the last operation that we are doing, this is the fourth operation. In here I'm just updating this, this the minimum exclusive is here now 9, and again shifting right 4216. Yeah, so I've done four operations here. So let's try to find out the patterns. It will be quickly observed here, and it is much intuitive. So I can see in the initial array, if I am given the k equal to 1, okay, so in the first, after the first operation, I cannot find this number 8 here. 8 is not present in this array. For the second one, second last element, the this element, this 10, it is not present in my second, after my second operation in this array. It is not present, right? This 9 is not present in the third one. This 6 is not present in the fourth one. Okay, so what I can see, the last three numbers, these I can see, these are getting repeated here. Then I will print the minimum exclusive here. Then I will print the initial one. Okay, this is the initial one. Got it? So first of all, I will find the my k. Once I got my k, I will move from, this is my n minus k plus 1th number, n minus k plus 1th number, and from the next of it, I will print all the numbers. then I will print the minimum exclusive, then I will print the numbers from 0 to n minus k plus 1. Okay, uh, sorry, n minus k. So till here I will print and this will be my answer. So but here there will be an edge case if k equal to 0. That means after taking the modulo k becomes 0. That means there will be no change in the array. So then in that case I can simply return the same array as before, right? So the code is also very much similar to that. I can show you the code. So here what I've done, I've taken the array, then I've just inserted in these into a set for taking a minimum exclusive, and if n is 1, then this the initial number will be getting repeated. That's why I've taken the complement of that again, and then I taken the modulo of k with n plus 1. If k is 0, then I've printed simply the initial array. Otherwise, I will print the last few elements from n minus k plus 1 to n. Then I will print the linear exclusive. Then from 0 to n minus k. And this will be my result. This was a pretty much simple observation based problem. So it could be also done by intuition, but it will this observing this pattern and solving this problem will could also work here, right? I hope you got it. If you are having any other doubt, you can comment in the comment section, right? Okay.